My name's Roger Gardner. I'm Rylan Sawyer.
Abram Garcia.
My name is Oseni Moayeni.
What is the function of the project? We know it's a turbine, but can you give us a little more than like why a turbine?
Traditional turbines are three-blade horizontal axis, so they spin like this. And those have a few advantages. They're generally pretty efficient. The problem though is all of our sites that are onshore have been mainly taken up. Right now, the big push is for offshore turbines. The problem with like the three-blade horizontal axis turbine is it's very top-heavy, right? Its generators up there, it has like its gearbox up there, so everything is really top-heavy. And so the thought is moving to a vertical axis turbine is we can have the generator on the bottom, any gearbox that we might have would go on the bottom, and it also works omnidirectionally, and so you get a lower center of mass and cheaper foundation systems, which is a huge cost of these offshore turbines. If the wind is blowing too fast, you start trying to harvest all that energy, we're actually wearing the system faster than it should be, and so it'll break down sooner. There's also like low wind conditions where like you need enough wind to start it up. It can be a very sophisticated problem, especially dealing with an array of turbines.
What are the next steps you and your group will take on this project?
So we have a test print of a cambered blade, which means the blade is, I don't know if you can really see it, but the blade is curved slightly.
Yeah.
So that way it interfaces with the wind a little bit differently. And hopefully that means that we'll start spinning at like a lower wind speed, which is nice. These don't take up as much space as a conventional horizontal turbine. So you can put this in other environments.
If you use a vertical axis, you don't need any system, right? It can just accept wind from any direction. And inside urban environments, because all the buildings, the wind is really chaotic. It's very turbulent.
For our side, the electrical team, we have 3 electricals, 3 computers, right? 2 of them are working on the user interface, right? And then us 2 we're working on the hardware side, take a look at it. But we have 2 generators right now, small generators. One of them's acting as a motor, the other one's a generator, and it's driving the other one, so we can get power output from that. And then hopefully next week or the week after that, we'll integrate the electrical and computer side of the stuff, right? And then the week after that, it's gonna be integration of everything. The normally open, it's connected to our rectifier here, so we can get DC power. So basically, it'll make the system independent. And then the other, the normally closed side of the relay is connected to these dump load resistors. So those are gonna act as like kind of like braking system for the relay, right? You can see on the oscilloscope here, we're generating power, right? And then once we open up the loop for the dump load resistors, you can see it, you can hear it slowing down. So basically you just take it from here and you put it in the turbine for them, and that's it.
So the tunnel, we were obviously granted access.
Gifted bishop.
Yes. And it had this pitot tube sensor for wind speed before, and it doesn't work, which we did not know at first. And it gave us a lot of headaches because we obviously assumed that our DAC system and our measurements were bad when it was actually this system that was bad.
Okay.
And so we're actually working with the Power Energy Society, and they have a lot of measuring devices. So they had an anemometer, and then we measured the wind speed, and we realized that our data collection system was actually the one that was accurate, and then this one was off by like 100% wrong.
So that's kind of off then.
Yeah, it was very off, and it was giving us a ton of headaches. Almost everything inside the tunnel was made in the makerspace. The main shaft for the rotor machined in the machine shop at the makerspace. It was also the technical advice for bearing fittings. Rotors or the current blades on there, resin printed in the 3D printer lab at the makerspace. The test stand over there for the generator was made this morning in the makerspace.
It's fresh.
It's
Yeah,
fresh. I still smell like wood.
Also, the generator that we have there to drive the other generators had it like a casing on there that we couldn't take it out, so we had to go to the machine shop and just what do you call that? I guess
Brute force?
Yeah, brute force your way into it and just remove the case out
It's
of
been a
it.
lot of help. And then we do have a locker in the makerspace, so it was really nice being able to have a public place to store stuff. Not everyone can go access it.
Yeah.
Right.
There's a lot of people coming through this lab, and so we're going over to the makerspace all the time for everything we need. So it's nice to have supplies that we need there as well. We're the Windrunners,
We're the Ghostbusters.
and you're watching Makerspace Mondays.
Okay.